Good morning, CP Pre-Calc. Today is March 30th, and we will be working on solving trig equations again. And this is day 3. All right, guys, day 3. Now, guys, what we're going to do is I'm going to go over again 2 equations. Just review some of the concepts from last week and maybe introduce some more concepts. All right, guys, we're going to be looking at that. Solving trig equations, day 3, March 30th. Okay, I think that's all in our video now. Now, our directions are going to be the same as last week. We're going to be utilizing our unit circle. So we are going to solve the trig equations. For exact solutions on the interval 0 to 2 pi. Now what that means, exact means that we're not using any decimals. Exact means that I'm going to need to use my unit circle, and I know it's between 0 and 2 pi, so I'm using radian measures on my unit circle because 0 to 2 pi is in terms of radians. Now I want you guys to be aware, when we take a look at that, when they say between 0 and 2 pi, that means 1 revolution around my circle. Between 0, 1 revolution. Any answer within that 1 revolution, that first revolution on my unit circle, must be written down. Okay, that's what they mean by the solutions on the interval between 0 and 2 pi. So let's start with our first example problem, guys. I'm going to go over 2 examples and really reinforce the concepts that we learned last week and just add one simple concept today, and then we're going to do a lot of practice on this. So if I take a look at my first problem, the first problem is going to be 2 sine theta minus sine theta plus 2 is equivalent to 3. Now our goal here, when we solve trig equations, our first goal is to isolate our trig term. So it's to get that sine theta by itself. Now in this case, I have sine theta appearing twice. However, they're both just sine theta. Not one of them has a squared. Therefore, these are like terms. Just like 2x and x are like terms, 2 sine theta and sine theta would be like terms, meaning we can combine them together. We can add or subtract their coefficients. So in this case, if you think 2 sine theta minus sine theta, that's a minus 1. 2 sine theta minus sine theta will result in sine theta. I can combine those like terms to simplify this to get one trig expression. So now I have sine theta. Now I just bring down my plus 2 is equivalent to 3. Now remember, our goal in trig equations is to first isolate that trig term, that sine theta. So the next thing I'm going to do is I'm going to subtract 2. And I'm going to get sine theta is equivalent to 1. Once we get here, we remember sine theta is y. So we know sine theta is y. So when I look at my unit circle, I am going to ask myself, what theta value, what radian measure gives me a y value of 1? And I'm going to look for 1 whole revolution. So if I go here and I look for 1 revolution, I'm looking at my y values. I start at 0. And I look, when is my y value 1? It's at pi over 2. So there's a solution, pi over 2. Does it ever hit 1 again? Look through 1 revolution of my unit circle. It never hits positive 1 again. I did 1 whole revolution. So that means I have 1 solution of pi over 2. And that would be my answer. So we're trying to find the radian measures in 1 revolution around the unit circle that will result in sine theta being what theta value, what radian value would result in a 1 for sine theta. All right, guys. Now let's see. Let's try another one. 2. 2 is going to be 4 tan squared theta minus 1 equals tan squared theta. Now this one's slightly different. I have tan except it's squared, but I have 2 tan squared. So again, we have like terms. Okay, so this is a 4 tan squared, that's a 1 tan squared, but they're on opposite sides of our equal signs. So what we would have to do is we'd have to subtract that tangent squared theta from both sides. Here it would cancel. 4 tangent squared minus tangent squared would be 3 tangent squared theta. Now they are like terms because they're both tangent squares, so I can combine them together. Now we're going to isolate that tan. Now my goal here is to isolate tan theta, meaning move the 1, move the 3, and get rid of the square. So I'm going to add 1 to both sides. I'm going to then divide by 3. And then I'm going to take the square root. And remember, when we take the square root, when we're solving, we have to take the positive and negative square root of the value. So I'm going to get tan theta is equivalent to positive, negative. The square root of 1 is 1. The square root of 3 is square root of 3. Now the difference here is tangent is equivalent to, remember, tan theta is equivalent to y over x. And I need to think, how can I get a 1 over root 3? And I want to look at my unit circle because I'm looking for exact solutions. I need to look at my unit circle. How can I get a 1 over root 3? Now, remember, y over x. So y, let's take a look here. I have 1/2 over root 3 over 2. This is my y, this is my x. Look what happens when I analyze that. I get positive 1/2 over root 3 over 2. If I take a look at that, I can multiply my numerator and my denominator by 2. They would cancel out. The reason I'm allowed to do that, because if I multiply by 2 over 2, I'm just multiplying by 1. I'm not changing the value of my expression. These 2's cancel, these 2's cancel. I get 1 over root 3, which is what I wanted. So the key here is once you get to this, if my root 3 is in the denominator and I'm looking for x to be root 3, I go to my unit circle and look where is there an x value that has a root 3 in it. And then I test that out to see if it works. And 1/2 over root 3 over 2 is going to simplify to 1 over root 3. So that will be one of my solutions. So that means if I look at that unit circle, I'm looking for x to be a positive or negative 1/2. And root 3 to be a positive or negative root 3 over 2. That's going to get me 1 over root 3 when I simplify it. So my first value was at pi over 6. My next value, x is negative root 3 over 2, positive 1/2 here for y, is at 5 pi over 6. My next value is going to be negative root 3 over 2 for x, negative 1/2 at 7 pi over 6. And my last one, I have positive root 3 over 2 for x, and negative 1/2, that would be at 11 pi over 6. All right, now that's a little trickier, but just be aware, you're looking, if root 3 has to be in the denominator, I'm looking for when y would be root 3. Now, if root 3 was when x would be root 3. If root 3 was in the numerator, I would be looking for when y would be root 3. All right? Now, the last thing I want to go over is just one more. We did this last week, but I just want to emphasize it one more time. Okay, guys? I want to emphasize this one more time. All right? If I have secant squared theta, all right, it's going to be minus 4 equals 0. All right, guys? How can I solve this? Now, first thing, I have a squared, I have a secant. I only have one of the terms, so it's not as bad. I'm just going to start by moving that 4 to the opposite side. And then taking the positive and negative square root of 4, which would be 2. The reason I'm going over this now is right when you get here, I want us to remember, we want to take the reciprocal. If I have a secant, a cosecant, even if you're more comfortable with the cotangent, but especially a secant and a cosecant, I want to take the reciprocal of both sides. And the reason why is when I take the reciprocal of secant, I'm getting cosine. If I take the reciprocal of 2, I'm getting positive and negative 1/2. I now know, and remember, cosine theta is equivalent to x. So therefore, when I go to my unit circle, I'm just looking for x. I'm looking for when x is positive or negative 1/2 on that one revolution. So I say, when is it positive, negative 1/2? Well, it's positive 1/2, x is positive 1/2 at pi over 3. I'm going around my one revolution. It's negative 1/2 at 2 pi over 3. It's negative 1/2 again at 4 pi over 3. And it's positive 1/2 again at 5 pi over 3. So going through one revolution, I just identified every single case where x is either a positive or negative 1/2. All right? Now those are 3 examples just to review and just recall combining like terms. So what you guys have today is a practice worksheet. I would like you guys to work on it and submit it by 8 p.m. tonight. Just try your best. I will put the answer key for that out tomorrow. In addition, I posted the answer key for March 26 and March 27 homeworks, day 1 and day 2 of solving trig equations, so that you can look over them. If you have any questions, if you have any concerns, please visit me on Canvas Conference during office hours. Please drop me an email if you need to, whatever would help you the most. And please attach the homework to the assignment tonight. Upload it to the assignment tonight. All right, guys, have a great day, and I hope to see you on Canvas Conference. Bye.